Hello everyone, welcome to Engineering and Economy. I am Dr. Nathan. Today we are going to study about series and parallel connection of solar PV module. So this series and parallel connection is the fundamental of solar PV system design. For example, if you want to install 5 kilowatt solar PV system, we have to buy number of solar modules. So each module probably will have 200 or 250 watts. The panels we call panel, 200 250 watts panels. In a general term we call panel. So we have to find a way whether we connect these panels in series. In technical words, is better we call is module. Whether we connect these module in series or parallel. So that is the question each solar PV designers has. So that is the fundamental block of the designing the entire solar PV system. Let's get into the video. So here look at this. We have 4 modules. Each solar PV modules will has 12 voltage and 5 ampere. So if we connect these all 4 modules in series, the voltage will be added. Series means simply voltage will be added. The current will be the same, 5 amps. So we'll look at the next panels. We have 3 panels. I'm using the word panel. It's very simple to explain, but in technical words it's a module. So we have 3 panels. So each panels will have 12 voltage and 5 ampere. So because we have a 12 voltage, 12 voltage, 12 voltage all added and become 36 voltage is a total output from the system, and current will be the same, is 5 ampere. So series connection is to increase the total voltage of the solar PV system. So it means if you want more voltage output from this entire solar PV system, you have to go with more series connections. In simple, like we put these 1.5 voltage batteries together in your toys, cars or something to make it 6 voltage. So if you put in series, we can make 6 voltage. In simple, likewise, if you put solar panels or solar modules in series, we can get more voltage. So let's go to next. Here series connection is look at three modules. We have 6 volt each. So because each are same 6 volt and 3 ampere, we will get 18 volt. 6 volt into 3 modules, it become 18 volt. So if you look at here, it's a simple diagram like how this solar PV is connected to the battery in series. So the series connection, you are like connecting the plus and minus of the neighboring solar modules. So we are connecting like this, and the negative will go to the battery and the positive will go to the battery. So resulting voltage will be sum of all the panel voltages. However, the total current will be equal to the output current of each panel or module. So in simple, if you want more voltage, we have to connect more module in series. So this is the best representation of series connection. If you have 2 panels, you can easily relate this series connection. This is like a one solar module, this is another solar module. You're just connecting, as I said, it's like a battery. You're connecting 2 batteries. Similar to that, we are connecting 2 solar modules. So in electrical theory, we are studying series circuits like this. So this is a series circuits usually we are studying. So you have to imagine that V1 is come from one of the solar module, V2 is come from another solar module, and V3 is come from another solar module, and this is the power source, and that going to connect it to the battery. Is the other way around. In the series circuit, we are saying the battery is connected to the load, but when we in the solar power PV system, we are saying that these are the power source. Those are solar panels that connected to the battery to charge the battery, or it connected to the DC load, and then it go to the inverter, and maybe it directly go to the inverter and go to the house system. So that's all for series connection. Next we go for a parallel connection. So parallel connection is simply like, you can understand that each module is individually wired. There's no like a jump between the each between the module. So it is individually connected. Look at the wires, it individually come to the source, okay, battery source. If you look at this diagram, we have three module connected in parallel. So each module have the same rating, 12 volt and 5 ampere. So when we connect each module in parallel, the currents rating will be added. 5 ampere plus 5 ampere plus 5 ampere, it becomes 15 ampere is the total output current. And the voltage will be the same because we are doing the parallel connection. So parallel connection is to increase the total current. So we can simply understand, if you want more total current as an output from this entire solar PV system, we need to go for more number of parallel connections. Earlier we said that in series connection, if we want more voltage, we are going for a series connection. If we want more current, we are going for a parallel connection. So if you look at here, that we have a 12 volt 5 amperes, again 4 panels connected in parallel. So the output will be 12 volt and 20 ampere, because each 5 ampere, 5 into 4, it becomes 20 ampere. So total current will be equal to sum of the output of current of each panels, and the resultant voltage will be equal to the each panel voltage. So this you can easily understand from this simple parallel circuit. We have in school days we might study this kind of circuits. We have two batteries connected in parallel to make more current, because if we, let's say this is 1.5 voltage battery, the total voltage will be 1.5, but the current, if let's say is 0.5 ampere, 0.5 ampere, so it become 1 ampere. If each 0.5 ampere means the total current will be 1 ampere. So next, so we completed the parallel circuits. Next terminology is PV string. So what is mean by PV string? Many articles in websites you might study the word PV string. Many students do not know. Many people do not know what is PV string means. PV strings means actually a series connected module. Let's say in this diagram we have three modules are connected in series. We call this as a string. A string which has three modules in series. So in simple, series connected group of module is called solar PV string. So why we have the string words, technical words come into play? Because we always have lot of series connection and less number of parallel connection. If you look at solar PV system, you can look at your rooftop or any other place. We are going to deal with more number of series connections, because usually solar PV panels might have 12 voltage panel, the modules, each modules, but the output we may want to make it like 48 voltage. So we had to connect number of panels to make 48 voltage. So that is why in the articles or and the many design ideas we call string means you have to imagine, when I call string, it's already have number of modules connected in series. The set we call a string. String mean, I will say like three modules, a string with three modules. So you can imagine this is the diagram. String with three modules mean I no need to tell that is a series connected. It is already known as a series connected, because the string word here means it is series connected. Okay, clear. So we'll go to next thing is a series and parallel connection, because it is a mix of series and parallel connection. So in the actual solar PV system, your rooftop solar PV or somewhere else, it have a series connection and the parallel connections. Both we have. So here, if you look at these two panels, I'll draw something over here. So these two are series connected. So look at this. This is a string. We can call this as a string. String 1. This is our string 1, because these two modules are series connected. 12 voltage, 10 amperes series connected. And this is another string, and this is the another string. It means we have three strings connected in parallel. So each string have 12 voltage. Each module have 12 voltage 10 ampere. It means each string has 24 voltage. Each string has 24 voltage 10 MVA. So we're talking about string here. This connection is easy for you to understand today's entire topic. Like, okay, this is a string. So how many string we have here? We have three strings. Three strings. Each strings have 24 voltage, 10 MVA. Because 24 voltage, because of series connections of these two modules, the total output from this string is 24 voltage, but ampere is 10 MVA is the same. So that's why when you have three strings, so 3, if you multiply this by 3 parallel, when it connected in parallel, voltage is same, but the current will be multiplied by 3, it become 30. So this is the understanding. We are talking about string, the word, technical word we are saying string. We have three strings connected in parallel. In simple, I can explain this diagram. Three strings connected in parallel. Then you can have to ask each string has how many modules. Then I will say each string has 2 modules. Then you will ask what is the rating of the module. Then I will say each module has 12 voltage 10 MVA. From this information we can design the system. So this is the another example of series and parallel connected. Again here this is a string. This string is a 2 module string. This is another string. These two strings they already mentioned here, string 1, string 2. String 2, this is string 1. These two strings come to the charge controller. That about charge controller I will explain in other videos. So this is the idea. String mean it's already is series connected module. Okay, this is very important because when you reading the articles or website, always they talk about solar PV string, string 1, string 2, string 3, and these kind of things. So you have to know it. Okay, that's all for today lesson. So what we learned is three things: series connection, parallel connection, series and parallel connection, and the word string. So as I already told, this is the fundamental of designing your system. If I ask you, can you design 20 kilowatt solar PV system with each module will have 300 watts. So 300 watts module, you're going to install how many modules? A lot of modules you have to install to make 20 kilowatts. So you have to design the system based on this idea. So I will tell what is the output voltage of each module and what is the output current of each module, and you can design the system to get 20 kilowatts as a output. And then we may need to specify that what is the output current and what is the output voltage. For some different reason I will teach you next lectures, we have to maintain certain voltage as an output, for example 48 voltage, certain current rating as a total solar PV output, because it goes to the inverter, it goes to charge controller. So a lot of things coming to next after the panels. So that's why it is important to design the system, arrange the system in series and parallel combination to make or to get a specific voltage and specific current as a total output from the solar panel. So that's all for today. Please subscribe this channel and provide your support. Thank you very much.